Did you know that the James Webb Space Telescope can see the light from stars that formed over 13 billion years ago? That's not just looking into the past, it's peering into the very origins of our universe. Welcome to Beyond Tech Tide, where we explore the frontiers of space exploration, science, and technology. Today, we're diving into the groundbreaking discoveries of the James Webb Space Telescope, a tool that's reshaping everything we thought we knew about the cosmos. Launched in December 2021, the James Webb Space Telescope, or JWST, is often called the Hubble's successor, but that's an understatement. While Hubble gave us breathtaking views of the universe's invisible light, JWST is a giant leap forward, capable of observing the universe in infrared wavelengths. This unique ability allows it to see through cosmic dust, detect faint objects millions of light-years away, and even look back in time to the very moment the first stars were born. But why do we need such an advanced telescope? What was wrong with the tools we had before? For decades, telescopes like Hubble have provided us with remarkable images of space, but they have limitations. Hubble mostly observes visible light and ultraviolet rays, which are blocked by Earth's atmosphere. JWST, on the other hand, has been placed far beyond Earth's protective shield, 1.5 million kilometers away, allowing it to observe the infrared light that's invisible to the naked eye. This is crucial because many of the most distant and faint objects in the universe, such as newborn stars and faraway galaxies, emit primarily in infrared. Now, with JWST's infrared eyes, we're able to uncover the hidden details of the universe's earliest moments and unlock cosmic mysteries we could only dream of before. So, what is JWST discovering? Well, where do we even begin? One of its most profound achievements is its ability to peer into the very beginning of the universe, uncovering galaxies that formed just a few 100 million years after the Big Bang. By studying these early galaxies, astronomers are gaining insights into how galaxies, and perhaps even stars, first took shape. In a sense, we're looking at the universe as it was in its infancy. One of JWST's biggest breakthroughs came when it captured images of the first galaxies ever formed, providing a clearer picture of how the universe evolved from a hot, dense state to the vast, intricate cosmos we see today. These early galaxies were smaller and less developed than our Milky Way, but their study could help us understand the crucial processes of galaxy formation and the mysterious forces that shaped our universe. But JWST is not just looking at the past, it's also looking for life in the present. With its advanced instruments, it's analyzing the atmospheres of exoplanets, planets orbiting stars beyond our solar system. And it's revealing surprising details. For example, it has already begun detecting chemical signatures in the atmospheres of exoplanets that may indicate the presence of water, methane, and even signs of biological activity. These discoveries are sending ripples through the scientific community, as they bring us closer to answering one of the most profound questions: are we alone in the universe? JWST's ability to study the atmospheres of these distant worlds is a game-changer for the field of astrobiology and could provide the first concrete evidence of extraterrestrial life. Another key discovery made by JWST is its exploration of star formation. Stars, the lifeblood of the universe, are born from massive clouds of gas and dust. But the process of star formation has always been difficult to observe. That's because these clouds are so thick and opaque that they block the light from the stars inside. Using its infrared capabilities, JWST can now peer through these clouds, revealing the hidden nurseries where stars are born. It's like uncovering the secret, invisible heart of the universe. These insights not only deepen our understanding of how stars are born, but they also provide clues about the origins of planets and even the conditions necessary for life to thrive. Perhaps the most jaw-dropping discovery so far is JWST's ability to study cosmic phenomena in unprecedented detail. Take, For example, the famous Carina Nebula, one of the most beautiful and mysterious regions of space. JWST's images of the nebula reveal stunning details of the stellar birth process and the interactions between light, gas, and dust that were completely invisible to earlier telescopes. These images not only challenge what we thought we knew about star formation, but they also open new doors to understanding the life cycle of stars, and how the very elements we're made of were created in the heart of dying stars billions of years ago. With each new discovery, the James Webb Space Telescope is expanding the boundaries of what we know about the universe. It's like we're witnessing the cosmos through a new lens, one that not only lets us see further, but also deeper, into the very essence of space and time. With its incredible capabilities, JWST is unlocking the secrets of the cosmos, secrets that will shape the future of astronomy, astrophysics, and perhaps even our understanding of life itself. What do you think about the discoveries of the James Webb Space Telescope? How do you imagine the future of space exploration unfolding in light of these revelations? Let us know your thoughts in the comments below. And if you're as fascinated by the wonders of space as we are, don't forget to subscribe to Beyond Tech Tide for more cosmic discoveries. Let's continue exploring beyond the stars, together.